Chapter 5, Part B, is the traveling waves. We want to discuss the wave motion and to know the equation of the traveling waves. First of all, what is a wave? A wave is a disturbance that happens in space and carries energy. It's a method by which information is transferred without the material making a journey. We have a lot of uh, classifications for the waves. According to their nature, we have mechanical waves and electromagnetic waves. The mechanical waves require a medium to propagate in it, but electromagnetic waves can propagate in vacuum like light. It's an electromagnetic wave. Also, according to the number of dimensions, we have one-dimensional, two-dimensional, and three-dimensional wave equations. We also have classification according to the direction of propagation of the wave. We have longitudinal wave and we have transverse wave. We want to discuss the one-dimensional wave equation. In order to discuss this, we will consider that we will have a pulse uh, as a function in x dash, and this pulse is traveling after time t with propagation velocity v, as if you have a rope. This rope as if you have a rope and you have a pulse on the rope. After time t, it will be in another place. After time t, it will be in another place, and so on. So, according to the propagation speed, we have distance from this point to this point. This distance equals the speed multiply the time. So, if at time equals 0, initially, we have the pulse like this. After time t, the pulse will have the same shape, assuming no losses, but it will travel a distance vt. So if y is a function in x dash, now it will be a function in x. X dash is this distance. X is from 0 to this point. So x equals x dash plus this distance. You will add x dash plus vt. So x equals x dash plus vt. X dash equals x minus vt. So if y is a function in x dash, it could be written as a function in x minus vt. This happens if the pulse is traveling in the positive x direction. You can make the same discussion if the pulse is traveling in the negative x direction, but now x plus vt. So the first information, we know that y is a function in x minus or plus vt. The wave is a function in time and position. Time and position. Negative is used when the wave is traveling in the positive x direction, and the positive is used in traveling in the negative x direction. This is the first information we got, that y is a function in x and t and not any function. They must appear x minus or plus vt, where v is the velocity of propagation of the wave. If we take this function and we want to take the derivative, we must specify if we want to take the derivative with respect to x or the derivative with respect to t. Taking a derivative with respect to x and y is a function in x and t. It's a function in two variables. X is changing and t is changing. So I cannot make the derivative. I make something called partial differentiation. Partial derivative of y with respect to x means I will differentiate the function as if t is a constant. So the partial differentiation of y with respect to x will make the derivative of the function f. Make it again to get the second partial differentiation, so you will have the second derivative of f. If I make the same discussion, but with partial differentiation with respect to t, I will have the f dash from deriving the function, but also I will have minus or plus v, because now I'm partially deriving with respect to t, and t is multiplied with a constant v. So when deriving the equation, I will have negative or positive v. Again, you derive this partially with respect to t, it will be v squared. Again, you will have v multiply v, it will be v squared, and you will not have a sign, f double dashes. Substitute with f double dashes instead of this one. You substitute with second partial derivative of y. This is called the differential equation of a traveling wave. You differentiate y partially with respect to t 2 times, and you differentiate y partially with respect to x 2 times, and you will find this satisfying the equation, and v squared is the square of the velocity. This is called the differential equation of the traveling wave. Now we want the equation itself. So the solution of this differential equation is a sine wave. So y is a sine, and I will write y sine x minus or plus vt. I wanted sine x minus or plus vt. Why? Because we said that the equation of the wave is function in x minus or plus vt. So I will write the equation of the wave as sine x minus or plus vt. But to be a general form, I will multiply by an amplitude, and I will multiply this bracket with a constant named wave number, and I will add initial phase. This is to generalize the equation. So y naught sine kx minus or plus kv t plus alpha. But we know that kv, anything multiplied with t, is the omega. The coefficient of t is always omega. So omega equals kv. From here, v equals omega over k. This is the general wave equation. Again, if I want omega t to be positive and kx to be negative, I can add 180 to the angle and no problem. So we can write the general equation of the sinusoidal traveling wave in one dimension. This is what you have to understand. The last discussion was just to discuss with you, but here is the wave equation we want to study. Y is the equation of the wave. It is a function in x and t. Remember that the simple harmonic motion was a function in t only. Now we have two variables, x and t, the position and the time, equals y naught, it's the amplitude. It could be named y naught or a capital, the amplitude. Sine or cosine, we said that it is the same function. The phase consisting of three parts: omega t plus or minus kx plus alpha. Plus when the wave is traveling in the negative x, negative when the wave is traveling in the positive x direction. Alpha is the initial phase. It is the phase angle at time equals 0. The coefficient of t is omega, which is the angular frequency and still related to frequency 2 pi f and related to the period 2 pi over t. Now the new coefficient is the coefficient of x. It's called the wave number k. So the wave number will be radians per meter, and it is related to the wavelength 2 pi over the wavelength. I will prove it now. But we know something else, that the velocity equals omega over k or lambda f. If you remove omega and put it 2 pi f, and you remove k and put it 2 pi over lambda, it will be lambda f. We want to prove this relation. This is the new relation we have. What is the relation between the wave number and the wavelength? The wavelength is the distance traveled per cycle. So if I want to calculate the velocity of the wave, it is the distance over time. The distance of one cycle is called the wavelength, which is lambda. The time of one cycle is t capital, which is the period. So velocity equals distance over time. But we know that the velocity of the wave is omega over k from this part. So I can equate omega over k with lambda over t. Omega over k equals lambda over t. K equals omega t over lambda. Omega multiplied t equals 2 pi over lambda. So the new relation is that the wave number is related to lambda. So if you will examine the wave equation, the coefficient of t is omega, and you can get from it f and t. And the equation of x is the wave number, and you get directly from it the wavelength of the wave. Now, if the wave is a function in x and t, and I want to draw the wave, I have to draw it with only one variable. So I will draw the wave with x. The wave, I will draw it with x. To draw it with x, I will put t as a constant, or I will put t equals 0, as if in the beginning. And for simplification, I will put alpha equals 0, the initial phase. I want to draw y naught sine kx. It will be a sine function. The distance from the crest to crest, or the trough to trough, is called the wavelength, or it is the distance of one sine wave. Distance traveled in one cycle. If I want to draw the displacement of the wave versus the time, now I have in this equation, I want to draw it with time. So I will put x equals 0 and alpha equals 0, or put x constant at any value of x. I have to put constant for the variable x because I want to change y with only t. So if you have y equals y naught sine omega t plus 0 plus 0, because I will put alpha equals 0 and x equals 0, it will again give you a sine function. So if you want to draw y versus t, it will also be a sine function. And the period of one oscillation is t. The period of one oscillation is t. If I put x, different x, but constant, at certain element x, x equals constant at certain position x equals x1. So this constant could be added to alpha to be another constant alpha dash. Now I will have y equals y naught sine omega t plus alpha dash. Y equals y naught sine omega t plus alpha dash is a simple harmonic motion equation. So each element of the medium executes a simple harmonic motion. We have a wave, but each element of the medium executes simple harmonic motion. Each particle executes a simple harmonic motion. So you can get the velocity of each particle by derivative of the equation of the particle or partial derivative of the equation of the particle of the wave. And you can get the acceleration of the particle by the second derivative. Note that this is called the transverse velocity and this is called transverse acceleration because the vibration of the particles are perpendicular to the flow of the wave. Now differentiate between velocity of the wave, velocity of propagation, and velocity of the particle. You have this particle is making simple harmonic motion. The second one is making simple harmonic motion. The third one is making simple harmonic motion. The second, and so on, and so on, and so on. And then simple harmonic motion, and so on. If you add all this, you will find the wave. So now, when dealing with the particle, we deal with the particle as if a simple harmonic motion. And how I add waves or superposition of the waves. Waves are superimposed or added if they satisfy three conditions. Same frequency, same velocity, and same direction. Check omega, omega, omega. So same omega means same frequency. Same velocity means if you have same k, you will have same velocity because v equals omega over k. Check k, k, k. Same direction, this is negative, negative, negative. So if I want to add three waves, traveling waves, I'm checking first omega, k, and the sign. After this, the resultant will also be a traveling wave. So y total, which is y1, y2, y3, will take the same form as one of them, but with different amplitude y naught total and different angle alpha total. So alpha y total is also a sign with this phase and amplitude. I will try to find this amplitude and this angle. Similarly, as we did before in the simple harmonic motion, you can calculate x, calculate y, and then you can get the amplitude and the angle. Let us solve some examples on traveling wave equation. This figure shows a wave function versus x. The distance from crest to crest is 40 centimeters. This is the wave length of the wave. And the amplitude of the sine wave is A, the amplitude of the equation. It is 15 centimeters. A traveling sinusoidal wave of frequency 8 CPS. We know that the frequency unit either hertz or seconds minus 1. Also cycles per second. This is the number of cycles per second. So it's the same as hertz or second minus 1. It's required to calculate the periodic time, the angular frequency, and the speed of propagation. The symbol of the periodic time is t. The angular frequency is omega. The speed of propagation of the wave is v. Okay, now I want to calculate t. T is the reciprocal of f, and I have f, so 1 over. If I know f or t, I can calculate omega because the three are related together. Omega equals 2 pi f. Then v equals lambda f or omega over k. It's direct substitution in my equations. Another example, it is given this equation of a mechanical wave. Let's read the equation together. Y as a function in x and t equals 15 sine all this. First of all, before asking anything, what is multiplied by the sine is the amplitude A. Inside the sine, we have the coefficient of t is omega. So this part is omega. The coefficient of x is k without the sine. The sine, if coefficient of x and coefficient of t has opposite sign, so the wave is propagating in the positive x direction, plus alpha, which is the initial phase. All what is in this bracket is called the phase. After understanding the wave equation, I will read the requirements. It is required to calculate all these parameters. Let's take it one by one. The frequency. The frequency is related to omega, and omega is in the wave equation. So F equals 2 pi over omega. The angular frequency, this is the angular frequency. The periodic time is related to F or angular frequency, so it's reciprocal of F. The velocity of propagation of the wave is omega over k or lambda multiplied F. The wavelength is related to k. So k equals pi and lambda equals 2 pi over k. Then the initial phase is what is added to omega t plus kx plus 120. So this is 120 is the initial angle. What is the maximum velocity of any particle? What is the total energy of a particle? 0.5 grams. For any particle, it is executing a simple harmonic motion. So V maximum will be omega multiplied the amplitude. And for any particle, the energy will be half m omega squared a squared, as we did before in simple harmonic motion. And you have the mass, you can substitute and get the value of the energy. Another example of the wave, an ocean wave generated by an earthquake propagates along the open ocean at 700 kilometers per hour. This is the velocity of propagation of the wave and has a wavelength of 750 kilometers. What is the frequency of the wave? V equals lambda multiplied F. If I want F, I have lambda and I have V. Get F. But take care, we must use the velocity with meter per second. So what is given is kilometer per hour. I will multiply by 1000 to have meter instead of kilometer. And multiply the denominator with 60 to convert hour into seconds. So instead of using kilometer per hour, I will use meter per second. Then I will divide by the wavelength. The wavelength is measured in meters, but here it is given in kilometers, so you have to multiply with 1000 to convert from kilometer to meter. The last example we'll discuss, it is given the wave equation. This wave equation, I want to get all the parameters of the wave. If you read the wave equation, the constant multiplied by the sine is the amplitude. The coefficient of t is omega. The coefficient of x without the sign is k. What is added to omega t minus kx is alpha, initial phase. Amplitude A, angular frequency omega. From the angular frequency, I can get two things, the frequency and the PL. And from K, I can get the lambda, the wave. After discussing all this, what also we can get? We can get the velocity, because the velocity is omega over K or lambda. And we know that the wave is traveling in the positive x direction. Thank you for listening.